Okay, so this is the second part of 2.2. And this part's a little easier because we've all done median and mode before. By the way, there's an easy way to remember median and mode. Okay, median. Think of the median as the middle. Median, middle. Okay? Mode, most. All right, so the median is exactly in the middle of our numbers. If we have an even number of values, it's good when it's odd, it's easy to see because there's always a middle one where you have the same amount of numbers on each side. But if it's an even set of data, suppose that 76 wasn't in there, then we would take the two middle ones and average them together. Some examples. 4, find the mean and median for the data set of all ages of college students in a small study group. If a student who is 55 years old joins the group, how would that data affect the value of each measure of center? By the way, mean, median, and mode, mean, median, and mode are all called central measures. Okay, measures the centers of data. Okay, so let's take a look at this. Find the mean, median, and that's okay, we'll find the mode anyway. Okay, so the mean, remember, we add up all the numbers in a data set and then we divide it by the number of data points that we have. So in a calculator, because I'm not going to do this in my head, I'm going to add up all the values. 18 plus 22 plus 25 plus 24 plus 19 plus 20 plus 19 plus 17. Okay, so let's see, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to divide, I'm going to hit enter. Okay, always hit enter before you divide by 8. So my mean is going to equal all the, here, let me put the definition down. All, the average of all the numbers which equals the sum divided by the number of data points. Okay, so I have 164 divided by, there were 8 data points, and that gives me a mean of 20.5. Let's see, this is 24, that's the age, so I'll say years. Now, the median's a little different, and the mode. The median is the middle of this. So the first thing we have to do is put these in order. So my smallest one, let's see, I got 17, 18, 2 19s, I have a 20, 22, a 24, and a 25. Okay, the median, again, I have eight data points, 1, 2, 3, 4, 5, 6, 7, 8. So the median I have an even number of data points. So I need to take the two middle ones, 1, 2, 3, 4, and 5, and take the average. So 19 plus 20 divided by 2, and the halfway point between 19 and 20 is going to equal 19.5. The median is 19.5. Now, if they were asked for the mode, remember the mode means most. The most times a data point occurs is the number 19. So that's our mode. Now, if 19 didn't have two of them, if there was only one 19 data point, then we wouldn't have a mode. Okay, so there's the mean, median, and mode. Then there's the second part of this question. If a student who is 55 years old joins the group, how will the data value affect each of the measure center? Well, it's really going to, it doesn't ask us to compute it. It asks how will it affect it. 55 is more than double the highest one. So 55 years old is going to what we call skew. 55 years old will skew the data tremendously. Okay. What I mean is by skew, it's going to really make this mean really going to go far out there. So this is actually what we call an outlier because it's so far from any of the other values. Okay. So that's how it will affect it. All right, second question here. The mean is affected by values that are much larger or smaller than the rest of the data, and is pulled in the direction of those larger or smaller values. However, the median is not as affected by extreme values. Thus, the median is the preferred measure of the central where there are extreme values in the data set. In other words, that 55 years old will affect the mean because the mean is the average of all the numbers, whereas the median is the middle. So you can have a value out here of a million, and your median still going to be really close to 19.5. In fact, it'll be 20. Make sense? All right. Number 5. Use the data of the annual salaries for nurses in the clinic to answer the questions that follow. So we have, let's see, 1, 2, 3, 4, 5 columns, 4 rows. So we have 20 items of data. So I'm going to write that over here because I'm sure they're going to ask us for a mean. 20 data points. What is the mean salary? So I'm going to have to add all of these up and divide it by 20. $31,200 plus 44,000 plus 54,000 plus 72,000 plus 31,200 plus 46,000 plus 54,000 plus 74,000 plus 31,200 plus looks like I hit the enter button by mistake. It's okay. 46,000 plus 63,000 plus 75,000 plus 34,000 plus 50,000 plus 65,000 plus 100,000. Wow, somebody makes a lot of money. Plus 35,000. Can't be the teacher. 31, or I'm sorry, 51,000. 70,000 and 125,000. So I'm getting 745,200. I just want to go back and check because I want to make sure that when I hit the enter button that I didn't miss one. 32, looks like 31, 2, 46, 63, 75, and then 34. I want to make sure I capture that 34,000. And 31, 2, 44, 34. Okay, it looks like I did. Okay, so my 70, I'm sorry, 745,200 and divide it by the 20 data points. 745,200 divided by my 20 data points. And the average salary then is 37,260. And that doesn't look right to me because most of these are way over 37,000. So I think there is a mistake in there. Nice. And do it again. 31,200 plus 44,000 plus 54,000 plus 72,000. Enter. I'm going to add each column up. This is 201, 200, 31, 200 plus 46,000 plus 54,000 plus 74,000. Enter. 205, 200, 31, 200 plus 46,000 plus 63,000 plus 75,000. 215, 200, 34,000 plus 50,000 plus 65,000 plus 100,000 gives me 249,000. And the last column, 35,000 plus 51,000 plus 70,000 plus 125,000 gives me 281,000. Now I'm going to add all these together. 201, 200 plus 205, 200 plus 215, 200 plus 249, plus 281. Enter, and then divide by 20. Yeah, much better. Much better. I get 57,500. Okay, kind of a pain in the butt, but especially make a mistake, at least I realized that it didn't make sense to me, so I went back and checked. Okay, what's the median salary? Uh-oh. Give us some long problems here to do. Okay, so first we got to put them in order, which they really are if I look at it from going across the rows. I have, again, 20, so I'm going to need the ninth and 10th values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Let's see, that gives us 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. These two. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need these two. So I need to take the average of 51,000 plus 54,000 divide by 2. Okay, 51,000 plus 54,000, enter, divide by 2, and my median is 52,500. Okay, which one is higher, median or mean? Let's see, mean. And it asks why. Well, mainly because of these 200,000 plus salaries, because it's kind of skewing the data of the first, wow, more than half of the values. So the two last salaries is skewing the data. Remember, outliers don't affect the median, but it does affect the mean. D, if nurses were trying to make a case for raising salaries, which measure essential should they use? Obviously, the median, because it's lower. They want more money. What is the most common salary? What could account for this? So the most common salary here, it definitely is the mode, which is 31,200. What could account for this? It could be relatively recent hires. There's a number of recent hires. I'm just going to leave it at that for now because I'm going to get myself in trouble. It is cumbersome to average all the data values at one time. Could you average each column and then average those results? Why or why not? No, you cannot for the mean, and I'll tell you why. Because um, you will be missing those outliers in the mean. Okay, it minimizes those outliers the way that they tell you to do it. Okay, so you can't. You got to include all of them at ones. Number 6, grade point averages, GPAs, are computed as weighted averages. Each course grade is weighted by the number of credit hours for the course. Use the information in the tables to calculate the student's GPA for each semester. Also, calculate the cumulative GPA for each semester, starting with the second semester. Also calculate the cumulative. So you got to keep going, and that's what the cumulative is. Okay, so first, we have to compute the weighted averages. Now remember the formula for weighted averages. Weighted averages are weighted mean. It's the summation of x times the summation of your x values times the weight divided by the summation of the weight. Okay, so the grades we have to replace with numbers. So a C is 2 points, a D is 1 point, a B is 3 points, and a C is 2 points. Okay, so the values then, so we're going to take our credit hours times the grade, that's going to be X times W. I'm going to make a column over here. I'm going to call it the X times W. X times W, 3 times 2 is 6. 6 times 1 is 6. This is my X, that's my W. 5 times 3 is 15. 3 times 2 is 6. If I add all these together, 6 plus 6 is 12. 12 plus 15 is 27, plus 6, 33. Better double check that. 21 and 12. Yep. So the summation is 33. So the weighted mean equals the summation of X times W, 33, and the summation of W, 2 plus 1 is 3, plus 3 is 6, plus 2 is 8. 33 divided by 8. And that gives me a weighted mean of 4 point, I'm going to round this, 4.1 for their grade point average. Okay, so I'm looking at this number, and 4.1 is more than an A. So something's wrong. I did something wrong. Let's see. I'm going to go back here and read. I computed as weighted averages in each, weighted by the number of credit hours. So my weight is actually the credit hours. I got these backwards. Okay, so my weight, I should have divided this by, see, 3, 6, 9, 14, 17. I should have divided this by 17. A lot easily to make mistakes here. And when I divide 33 by 17, I don't get 4.1, I get 1.94. Well, that makes more sense because they have D's and C's mostly. GPA. Okay, next semester, be a little more careful. Credit hours is my weight. Grade is going to be the X values. Okay, so 2 points, 2 points, 3 points, 2 points. X times W. Let's see, 6. 3 times 2 is 6. 5 times 3 is 15. 3 times 2 is 6. I need my totals. 6 plus 6 is 12, plus 15, sorry. 15 is 27, plus 6 is going to be, let's see, 27 and 6 is 33. Okay, the weight. 3 plus 3 is 6, plus 5 is 11, plus 3 is 14. So my weighted mean is my 33 divided by 14. 33 divided by 14 gives me 2.35 for this semester. Next semester, A is 4, 4, 3, and 4. X times W, 12, 12, 12, 12. 12 times 4 is 48. My weight is, this is my W and X. 6, 10, 13. So my weighted mean is the summation of X times W, which is 48, divided by the summation of the W, which is 13. 48 divided by 13. This GPA for this semester is 3.69. And I think, what was the other question they wanted us to do? Also calculate the cumulative GPA for each semester, starting with the second semester. Cumulative, so the first one was 1.94. I'll zoom out here for a minute. First one was 1.94. So this is cumulative GPA. 1.94 plus the second one was 2.35. Third one was 3.69. We're going to have to do the average of those. So we're going to divide it by 3. And cumulative GPA then is going to be 1.94 plus 2.35 plus 3.69. Cumulative GPA then is 7.98 divided by 3. It's going to be 2.66. So like a C plus. And the last question. Why don't the strong grades in the fall semester of the student sophomore year raise the overall GPA much? Because it actually did. It had to overcome 2 GPAs, not just a one low one. So 67, 2/3, or 67% of his GPA is 2.35 or less. That's why no matter, even though the third one was really high, it had to overcome 2/3 of the GPA. Okay, that'll do it for the second part of 2.2. You should be able to do the rest of the homework. However, you do not have to do not do 8. Okay, 8 or 9. Actually, you can do 9. So just don't do 8.